Hi, I'm Dan Michasuchu. Welcome to Software Project Management Course Notes, a podcast created based on Agile software development online classes I deliver to Software Engineering Master Program at the Faculty of Mathematics and Computer Science from Babeș-Bolyai University. I said that I will do a comprehensive comparison between agile methodologies and waterfall or traditional methodologies. And this is the overall picture on those methodologies. And the name agile pinpoints one of the key attributes that all these methods or these methodologies share. What image does this word agile bring in your mind? So someone who is agile is able to move quickly but decisively, to react to changing situations with speed and somehow with grace, and to change direction while maintaining his or her balance. And this image contrasts sharply, we can say, with the more traditional software development methodologies, which more closely resemble a large military encampment. These methodologies commit to a war plan. It's a march forward toward the stated goal. And we try in our way to control and mitigate any outside effects. And this is opposed to accommodating them, as is the case of agile methodologies. We can feel this based on the, let's say, how we perceive in those different situations this iron triangle. I think you already know that there are three important factors of success for any project: is the budget, the time, and the scope, or if you want, the requirements. And usually in a traditional project or in a waterfall project, requirements are fixed, the scope of the project is fixed, and the budget and time are negotiable, are debatable. We can negotiate on them. But it is very important that the requirements are fixed and we know very well which is the goal. In an agile context, this triangle is somehow rotated, and in this case, we can say that the resources, the budget, the resources, the team, individuals are fixed. Also, the time period is fixed, and the scope is negotiable. Usually, we are working in cycles of 2 weeks, or 3 weeks, or 4 weeks, or even 1 week, a 1-week cycle. So it's a time box there, and we have a limited number of resources available during that time box. And the idea here is how much we can do, how much effort we can spend, how many user stories we can develop, how many tasks we can implement. And this is what we negotiate with our clients, with our customers, at the beginning of every cycle. So it's a different view, a different perspective of this triple constraint, of this iron triangle. So this is the overall picture, but let's see other aspects of our projects. For instance, the relationship with the change. So the agile mindset treats change as an equal partner, if I can say this, as an equal partner in the project. Change is welcomed and encouraged to shed new light and introduce new information continually throughout the project. And agile methodologies are designed not just to accept change, but also to welcome it and capitalize it, to transform it in value for the client, for the customer. Remember that second principle. Comparing to agile methodologies and traditional methods, those traditional methodologies treat change as an enemy. So it's not a partner at the table, it's an enemy. So, of course, that traditional methodologies accept that it cannot be avoided, the change cannot be avoided. So they spend significant effort to control it and to mitigate the effects, to mitigate its effects. Most methods handle those changes in a change request system, and each change is interrogated, is examined in an effort to determine what should be done about it. There are a lot of approvals to be done in order to accept a change in the project. So it's a really different perspective and different way to handle a change. And you know, when I worked in waterfall projects, waterfall software development projects, usually the contracts on those projects were inflated. What does it mean? The customer used to inflate the specifications, and we, as a development team, used to inflate the estimations. Why does it happen? Because there were a lot of things we didn't know from the very beginning. The customer was trying to add as many features as they could from the very beginning, just to not forget anything. And they added a lot of nice to have features, some features they didn't really want it, just to be there, to be in the contract, in order to not forget something. Maybe they will become important in time. So let's add in there those things, and the specification document was huge, with a lot of things which were not very useful, which didn't bring any value to that customer, unfortunately. On the other side, because of this complexity, we try to inflate the estimates. For instance, I used to add 20% to all estimations did by my colleagues from the projects I managed, just because I knew from the past, from my experience, that usually those estimations are wrong. So I added those 20% from my side, and I presented it to the customer. But it was an artificial inflation. I was not sure that 20% was a right addition, that it will be enough in order to cover everything and to develop everything, or maybe it is too much. It was just a supposition, but we added there those times just to be sure, just to not risk too much in and to not have too many things to negotiate with the client when the end of the project approaches. And as I said, this is the way a traditional methodology, a waterfall methodology, treats changes. It tries to control. There is a control mechanism for handle changes. Comparing it with what happens in Agile when the change drives the development of a project. And usually it's something considered very important, and we want to be able to change our direction in the development very, very fast. About planning, is the same discrepancy, I can say. A controlling type of organization might face some challenges in adopting an agile method because these methods tend toward being reactive to change. So the project plans and the initial requirements are often treated as approximations, with the assumption that as the project moves forward, both the client, the customer, and the development team will learn about it. And I think most of agile methodologies use time boxing to control schedule and rely on customer to prioritize functionality that will be delivered. But this is the key, cooperative customer. Is the key to making this arrangement to work. We have to be very close to our client, to be very close to our customer. Although planning is as central to agile methods as to any traditional method, the agile methodologies treat deviations from plan very differently. When an agile project does not progress as planned, the methods treat that deviation as new information about the project, and they generally replan everything in the light of that new information. So their goal, the goal of such of those agile methodologies, is to bring the plan into conformance with reality, not the opposite thing. Because in the more traditional methods, they view these deviations from the plan as something which is undesirable, is an undesirable event. That's why they react to those deviations by adopting some corrective actions. In extreme situations, those corrective actions may involve replanning, but these methods much prefer to bring reality back into conformance with the plan. So again, in Agile, we try to change the plan to reflect the reality. In traditional methodologies, we try to change the reality just to be synchronized with the plan. With that plan, we created, we defined upfront at the beginning of starting the development of that project. So two very, very different ways to approach that project. Also, in traditional and in agile methodologies, we have an incremental way to develop a project and an iterative way to develop a project. Which is the difference between incremental development and iterative development? And I took here an example. This example is taken from Jeff Patton, a very well-known agilist. And he gave this example. Let's suppose that I want to have a painting of Mona Lisa on the wall in my apartment. Of course, that I cannot afford to buy the original painting with Mona Lisa. But also, I don't want to have a photo on that wall. So I want to have somebody to reproduce the original painting and to create another painting identical with the original one. In that case, I have to find a specialist, a person who is able to reproduce that original painting. And most of the time, that person will paint that painting in an incremental way. It will be something like this. In the first phase, it will do a part, a module, a component, let's say a part of that painting. After that, another part and another part and another part. This is the incremental way. And this is the plan-driven way of developing a project. I don't need any status report in this case. I can visit that painter and just looking on his painting, I know that it's 25% done, it's 50% done, or 75% done. I can see the evolution of this painting. But this is doable when you have the original version. And Leonardo da Vinci didn't have this luxury, so he had to approach painting that to paint that painting in a different way. It's called evolutionary way, in an iterative way. He did a very, very simple sketch because the specifications were not so clear. It was something like make a portrait of a woman outdoors. That was the specification from Giocondo, the husband of Mona Lisa. And first of all, Leonardo da Vinci did a very simple sketch, and he tried to get a feedback on the sketch. Maybe the feedback was, I don't like that head, which covers my mouth. I want to see the smile in the painting. He changed that sketch. After that, he added some colors. Based on the feedback, changed a little bit of colors, and step by step, he approached the final version. Now, what is very important to understand here is that no one, no Mona Lisa, Giocondo, or Leonardo da Vinci knew how the painting will look like at the end. The goal was clear. It should be a portrait, but they didn't have many details about it. And those details were discovered and they were followed during the development, let's say, of this painting, during the creation of this painting. It's a completely different way of doing it. And of course, that in most of those kind of activities, this is the way. It's the iterative way to approach it. This is another example of an incomplete painting from Paul Gauguin, which shows that there are parts which are very easy to be changed because they are not final. They are not in the final phase. But also we have a part of this painting which is in the final phase, because we are sure that this is the way we want to look that part of that painting. But we can change many more things on the other part. And this remained as it is. It's unfinished. But it doesn't mean that this evolutionary iterative way is an agile way of doing things. In agile is something somehow different. It's both incremental and iterative. What does it mean? Look, in traditional way, we used to start with those tasks which are very, very simple. And after that, we approach the more complex tasks and so on, and we let the most important things, which needs a lot of effort at the end, after we gain a lot of experience in our team. So in that case, we approach this painting in this way, maybe something like this, step by step, phase by phase, and in the end, we understand that we don't have enough time to finish the painting, and we try to do our best in order to meet the deadline. And maybe the result is something like this. It doesn't bring too much value to the customer. In this case, the customer is not very satisfied about the result. Now, in the agile way, it's very different because we start with the most important feature for the customer. That feature that brings a lot of value to customer business. And also, we try to find all those important features, all those, let's call them must-have features, and we start with implementing them. And most of the time, after implementing those most important features, we have a product which could be used, which could be delivered. So it's a minimum viable product, let's say. We can say that if it is necessary, if there are no, if there is no more budget left, we can stop there, and we have a product. It's not the whole product we imagined in the beginning, but it is something which could be used by the client, by the customer. So we, as I said, we always start with what is important. So we start with a smile, with a face, after that we add more and more and more. We can stop at any time. We can put everything in a frame and put it on the wall. It is okay. It is a very good painting. But if there are other requirements from the customer side with nice to have features and so on, we can add more. If there is budget, if there is time, and so on. If the customer wants to invest more in the product, we can add also those features, but they are not mandatory. I must say. Anyway, we can have only this. Again, put it in a frame. It's a very good painting. And this is the way we approach the design, the architecture of a software product, the development of a software product, usually in an agile way. Maybe you think that this cannot be done with architecture. We cannot have an evolutionary architecture. And I would like to show you, it's only 1 minute or 2 minutes, a very short movie about how such an evolutionary architecture is created, is built.
You're not going to see a complete application at the end. You're just going to see the first 100 hours. So I said, well, let's start with a savings account, see what we can see. First thing I did, put in some methods to manipulate that savings account. Realized that I was dealing with a year, not the whole savings account. Kept building that out. This is now a couple of hours in. Fairly soon, oh, you can also see how I'm reordering the methods too. That's why the things are moving around. About 2.5 hours in, I realized the need to start pulling out value types. So tax rate, interest rate, dollars, that's all what's come out there. And that was done enough that I could start building an application. This is a GUI-based application. It's in Java using Swing. So I needed a stock market table model to make the grid work in Java. And that's what you see me doing there. That drove the need for a stock market class, which forced me to come back to my core domain abstraction and build that in. You'll notice that I didn't start with any packages, but as the code got bigger, I realized the need for packages and I split it up according to what seemed to make sense based on what I had. Built some utility classes, kept working in the domain layer. Once that was working fairly well, I started bringing in the UI piece of it. And that's that forecast table class. And then building the overall frame. As I was working on the application frame, I built a model piece. I put it in the wrong package. I don't know why I did that. It was a UI component, not a domain component. But because it didn't have any direct UI stuff, I put it in that other package. But you could see how the arrows were going, crisscrossing back and forth. And that forced me to realize I had it in the wrong place, and I moved it into the correct package. Started bringing in UI for the editing the dollar amounts. And that forced me to have to deal with what happens when somebody types in an invalid amount, which created this new structure on the right with a superclass of dollars and then the null object pattern to handle invalid dollars and valid dollars.
Okay, I really hope that the sound was good, but you at least I think it was enough to get the idea, the main idea here. So there are two important things to be said on this example. The first one is that we are not able for such a complex for very complex software applications to build a perfect architecture from the beginning, to build a perfect architecture upfront. We have to start building feature by feature, and for each feature, we have to create, I don't know, database tables, the classes, the attributes, the methods, which are necessary for that feature, no more. No more and no less. And after that, for the next feature, we add more components, we add more classes. Sometimes we think, whoa, we could split this class because it became too big in two small classes. Maybe again, we should think to another level of abstraction and put a inheritance relationship between those classes and so on. Or maybe we can merge two classes in one because it seems more being more natural. Anyway, the second idea here is that we are not able to predict that the architecture will look like this from the beginning. It became like this working on those features, and those features are working software, represent working software, things that could be used, things that could be tested, things that could be validated by an end user. And we obtain a more flexible architecture, a more dynamic architecture, which allows us to change that architecture in an easier way, to add features, new features, or maybe to remove some features more easily. This is, I think, very, very important. If we try to design the whole architecture upfront, it will become too rigid. It will be very difficult to be changed during the life cycle of the project. Anytime when a new change comes from the customer, from the client, it will be a nightmare, I assure you, to change that architecture. So we have to be very open to modify again and again and again, and to create this as an architecture again in a evolutive fashion. Another thing I want to emphasize here is that any project, even if it is a complicated project or a complex project, is built in phases. We have phase one, we have phase two, we have the last phase. No matter if we approach it in a traditional way or in an agile way. But the most important difference between agile and waterfall, between agile mindset and a traditional way of doing things, is what a phase means here. What is in one phase? What is developed in one phase? And usually in a waterfall project, every phase represents an horizontal slice. We have the whole product, the final product, split in slices, horizontal slices, and we build them one by one, starting with the first one at the lower level, and after that to put again and again and again other slices above. It's like building a house, isn't it? For the first slice is the foundation. After that, we have the walls at the first level. The second level, and the roof is the last slice. Let's say we cannot use that house. We cannot move in that house till that house is not done. Till that house is not finished. Uh, but in Agile, it's different. As I said, we have vertical slices. If you want to build, which is unusual, if you want to build a house in an Agile way, we should do a little bit of foundation, a little bit of the walls at the first level, a little bit of the walls at the second level, a little bit of roof, and ask the client to move there and to give us a feedback. What he thinks about that slice. Should we change something there, or we can go with the other slices and finish the house? In the meantime, that client can stay there. He can use the house, the part of the house which is already done. Again, it is unlikely to build a house in this way, but this is the agile way. So if we think at a software application, in a waterfall way, if we build that application in a waterfall way, the first thing would be to, I don't know, to design the database structure. After that, to build the backend. After that, to have the front end, and we have the application. Every level represents an horizontal slice in our product, which is not okay because we need feedback. And who can give us a feedback on the structure of our database, on the architecture, on the design of our database? Somebody who is an expert in software development, somebody who is an expert in designing databases. Okay, and we get his feedback, and we start building the next slice. But what is very important here is to have the feedback from the final customer. There is no final customer who can give us a feedback on the architecture of the database or on the backend infrastructure. No one can give us a feedback. So what we have to do, we have to split everything, as I said, in vertical slices. So the first one could be, I don't know, user management. Okay, so we will create enough tables to store their usernames and password. We have to implement at the backend level just enough to be able to read, to analyze and check the passwords and usernames. And for user interface, just enough to allow a final user to log in, to log out, to register, or maybe to modify the profile. And that's all. And after everything is done, after this vertical slice is done, we can send it, transfer it to somebody to check it, to give us a feedback, and to tell us how much that feature corresponds to his or her expectations. And this is what brings value in an agile project because this feedback is very important. We don't want to have this feedback at the end of the project when everything is built, when everything is developed. It could be too late for us. It will be a huge effort to implement all that feedback in our application. So we'll do it step by step, slice by slice, but it should be a vertical slice. So what I wanted to represent here in this slide is let's say, a classic example of the differences between waterfall stages, waterfall phases, and agile phases in case of building a car. So in a waterfall way, how we can build a car, it will be component by component. And after that, we put all those components together, and we have eventually the final car, and we will give that car to the customer. And the customer will be satisfied or not so satisfied, but he knows that at that moment, nothing can be done. Nothing can be changed. This is the car which was created. He has to use it. In agile world, it's somehow different. So in the first, okay, I know that it's a metaphor. It's very difficult to do it in practice, but conceptually, this is the way we develop products in agile projects. First of all, the idea here is like this. We will ask that customer which is the most important feature of that car, which is the most important value you will have by using that car. Why do you need a car? There are a lot of reasons, but I think that the most important one, the most important feature is to go easier with a higher speed from point A to point B. So to reach point B as fast as possible. This is the most important advantage, the most important value of the product. So first of all, we will develop a skateboard, and we will ask the customer to use it and to give us a feedback. And based on that feedback, we will build the bicycle, and after that, the motorcycle. And at the end, we will have the car. Now, of course, that the cost of building that car is much higher when we do it in an agile fashion than when we do it in a waterfall way. The time needed to develop it is higher. Also, in this case, the effort needed to develop that car, to build that car, is higher. Anyway, the satisfaction of the customer is also higher. Why? Because that car includes all the feedbacks we received during the development cycle, during the life cycle of the project. And by the way, that customer didn't have to wait till the entire car is ready, the whole car is ready, in order to use it. He had the opportunity to use some intermediary versions, some intermediary releases. Those releases bring some value to that customer, to that client, before having the final version of the product, which is again very important for the customer business. Why we did this? Because there are a lot of things, a lot of details we don't know from the very beginning. They are not specified. There are a lot of things which are uncertain, which are ambiguous, which are volatile. Okay, so that's why an agile way of building that product is necessary, and this is the main difference. Another important difference between a waterfall and agile. Again, if I would like to ask you to give me a feedback about a cake, you need to have a vertical slice of that cake in order to have a good feedback. If we will give you only an horizontal slice, it's impossible to give me a useful feedback, a relevant feedback about the quality of that cake. So that's why we did working on these vertical slices. Thanks for listening to Software Project Management Course Notes. If you enjoyed this episode and you'd like to help support the podcast, please share it with others, post about it on social media, or leave a rating or a review.